Hello, friends. My name is Derek Harder, and in this set of lecture videos, we're going to be looking at what is TensorFlow and what is Keras. So this is from Chapter 3 of the course textbook for this. So this should be a relatively short video. Oh, by the way, I will put some links in these videos in the descriptions about the course textbook and where you can get these slides and other resources. Um, let's start with just a real quick little bit of discussion about what is TensorFlow. So we got into this a little bit in the previous. We had a little example of using TensorFlow and the gradient tape. So so we said a little bit of this before. TensorFlow is a Python-based, a free, open machine learning platform. Its primary purpose is to enable researchers to manipulate mathematical expressions over numerical tensors. Okay, and I probably would have added that to also support automatic derivation, so automatic calculation of gradients by building a computation graph. Okay, so that's one of the big differences between TensorFlow and NumPy. Basically, is that automated differentiation that TensorFlow supports. So TensorFlow does scale fairly well. So by scaling, what we mean is that it's relatively easy to parallelize. Okay, so there's different things you can do, and I'm not certain. We might do a little bit of that in this course, but that's mostly only useful like if you have multiple machines or like multiple GPUs in a single machine. But for example, one of the easiest kinds of things you can do is you can take the same computation graph and have it run on different machines or on different GPUs, and just have them each feed different batches. So they update their set of weights separately, and then there's a way to merge the weight updates that have been done in parallel at some point or at different checkpoints. But that's pretty important. So to actually do kind of modern deep learning, to train LLM models or generative vision models, things like that, you need large numbers of GPUs running in parallel. So you have to scale things out to multiple machines. TensorFlow, it does differ from NumPy. So we mentioned this one. The big one is the idea of automatically building the computation graph, and from that being able to automate the process of backpropagation and computing the gradients for you of any differentiable expression. Another big difference is that TensorFlow, the big thing that TensorFlow does is it does support different kinds of back-end computation, CPU, GPU, and TPU. Right? So GPUs are graphical processing units. TPUs are tensor processing units that Google and some other kinds of places are trying to develop. So the bigger thing on that, I'm going to talk a little bit more about GPUs here in a minute, but you can get much higher performance on a GPU or a TPU than you can from a regular CPU because of the way they work. So it's a big thing that you can basically built in have it so you can target a GPU or TPU to do your training or do your inference when you're using TensorFlow. One of the reasons why TensorFlow scales fairly well is that the computation that's defined by the computation graph can be relatively easily distributed in different ways. And TensorFlow programs can be exported to other runtimes, and also you can actually have other front ends above TensorFlow rather than something from Python. So different languages, C, C++, other things like that. You can use TensorFlow. There's a little bit of a discussion in this chapter at the beginning on what Keras is. So you should also kind of be familiar with the ideas of the basics of Keras from some of the previous stuff that we looked at. After this video, the next two videos from my the part 3 of the series is, we're going to look at more details of TensorFlow and discuss more details of TensorFlow and how it actually works, and then also of the Keras API and how it works. So this is kind of a good diagram, conceptually. So Keras is really a high-level API built on top of TensorFlow. So, so the job of TensorFlow is to define a computation graph and to be able to provide and run that on different kinds of computation platforms, CPU, GPU, or TPU. Keras is also a deep learning API for Python built on top of TensorFlow. Keras is a high-level API. So what we mean usually by high level is it provides very high-level abstractions. So when you use something, it hides a lot of complexity. So that means, experienced developers use that because it prioritizes the developer's time over having a lot of power. Right? So if I need most of the common things, I can build just with Keras, and because it's so high level, I can do them relatively quickly, right? But not everything. So once you get into deep learning, you will start to get into problems that aren't usual, and you can't do relatively easy with the high-level Keras API. So you can always drop down into TensorFlow and build things more at that level in order to fill in or get the kinds of things that you need that aren't kind of typical, that 99% of the users do with deep learning. So since Keras is built on top of TensorFlow, it can also easily run on GPU, TPU, or CPU computation engines, and also for the same reasons, it's relatively easy to scale when you're using the Keras high-level API. So I already mentioned this. So it does support several ranges of workflows. So this stack, the Keras TensorFlow deep learning stack, supports several ranges because you can do 99% of your stuff in the high-level API and do it quickly. But if you need to, you can do more complex and not as usual stuff by dropping down TensorFlow to add in pieces as needed. Okay, and then finally in this video, just some quick advice about setting up a deep learning workspace. So for students in my class, you don't necessarily have to have access to a GPU. So in fact, the assignments that I'll give you have to run in the autograder on GitHub, which is not going to have any GPU resources. It's going to be kind of limited on computation. But with that said, it would there are going to be certain things when you're using the reading materials and the resources from the class where it would be useful to have access to a GPU to do more, or at least to not be so painful if you want to run slightly more realistic examples that won't take you days or even hours to train and see what the results are. So, if you have access to an NVIDIA GPU, that's certainly the best thing. And if you don't, but you think that you want to get into and do deep learning as kind of a career or more often, you should think about getting access to a physical GPU, maybe through work or, through personal resources, set up a deep learning workspace. There is, if you absolutely can't get an NVIDIA GPU, you could buy time on like Google Cloud or AWS, but that's going to be really expensive. So very quickly you'll spend as much as you could to buy like an NVIDIA GPU. Although, well, you'd have to have the GPU and the system that can run with it. So, but yeah, usually pretty quickly there'll be quite a bit of expenses. Although you can sometimes, and you might be able to get to right now, get some, for initial sign up, get a bit of free time, so you get a little bit, that might include some GPU instances. I would recommend that if you can't get a physical GPU, probably not going the cloud route. Google Colab will give you some free access to GPU computation. It is limited. I haven't looked at it in a while, so I'm not certain what the limits are. But for example, for the assignments or even the lecture notebooks that we have in this class, you could put those up or copy those up and probably run them for the most part in Colab, or at least pieces of them. Just some quick links. I've been motivated to upgrade some of my own personal systems for this summer class that I'm doing some of these lectures for. So just some examples, some links if you are interested in kind of setting up your own environment. So I found this one to be a good one, so from 2023. Detmer. So in particular, if you scroll down, not to the bottom, but not too far down, there's some good summaries, and not to mention there's some good reading in here. Oops. Oh, that's fine. So, for example, so since this is from 2023, it doesn't have the 5,000 level NVIDIA cards yet, so it goes up to the 4,000 levels. But this is just the overall performance of some of the range of the NVIDIA products. So the difference between training and inference is, like in this class, we'd probably be more interested in training performance. So we want to build and train new models. But, you know, if you get into data science or a machine learning engineer, you might end up being focused on kind of the back end, where you've got a model, but you need to put it into production, and it needs to have high performance when you have new data coming in to make inferences and predictions and things. So, so this is the back end inference. Or yeah, if you're working with like already trained like LLMs, that would be where, you know, it's really already trained, but you need to know kind of how well it does on inference performance. The graph right below that is scaled performance relative to the cost, at least in 2023 here. So this is kind of useful, like if you are, you know, a bit budget conscious and are purchasing your own GPU. So for me, for example, I should probably save some of this for, I tried to do a little bit of a separate video of kind of setting up an NVIDIA GPU and doing like GPU pass-through for like Docker containers and things like that. So, but here, like, you know, if you have like a budget range, for me is like personally like $250, you can go through and look at this and kind of try and find like maybe on Amazon, or if you want to be even more budget conscious, maybe kind of search for a pre-owned one like eBay or something like that. So right now, from my experience in 2025, you're around the $250, $350 range, is somewhere in here, the 30, 60, 70, 90s, I think. Right, so there's I did end up settling on a 3060. That extra memory on 3090 would be kind of nice, but yeah, they were kind of more like $100 more for the cheapest ones I could kind of find at this point. So, all right. So anyway, that's all I'll mention about setting up a deep learning workspace at this point. Look for my other videos on this if you're in my class, for maybe a little bit more if you're interested in those kinds of topics. So, all right, so that's it for this video. I hope that was useful for you. Kind of just in summary, this was just a quick discussion of Keras and Tensorflow. Probably you were kind of aware of all this already if you've done the materials in chapter 1 and 2 before this, but also then just a little bit about setting up a deep learning workspace. And maybe we'll go into that more into some other resources for this class. Thank you for watching, and stay tuned for the next 2 videos of this, though we will go into the actual kind of details of some more details of how to use TensorFlow and what the TensorFlow API is, and how to use Keras and the Keras